Welcome back, Science 7. Starting today, we are going to learn a new unit. This unit is called heat and temperature. And as you may notice from the background of this PowerPoint slide, you may notice that you see a lot of laboratory instrument at the background. You see solution, you see some heating plate. You got it right. There are a lot of chemical reaction occur. This is actually one of the first field of science that you're gonna go through. And this field of science is known as chemistry. Chemistry is talk about the chemicals and how the world is running. We use a lot of, how can I say, benefit of chemical reactions. And obviously, we're gonna focus on anything that involve heat energy. So have that in your mind. Chapter one, we're going to talk about human needs and how that human needs or requirements have led to technology for obtaining and controlling heat. Because if you think about from very ancient time, we have used a lot of heat energy for basic conditions that are required for us to live. Let's go through our very first part, history of heat technology. Well, throughout the history, humans have attempted to define heat and use of various purpose. Even though I'm going to define about this term a little bit, heat is a form of energy. So basically, if something uses heat energy, it's gonna turning into something else to make the work done. So a lot of technologies that involve engines use, like what I put, as you may notice, heat energy is used in many different type of format. You see a little blimp over here. You see boiler, which is available for most of the household. You see the boiler feed and then valve that goes under the pipeline or over the pipeline. And by doing that, we actually can activate the pump and make the work happening to operate a machinery, those kind of thing. It is a complex procedure, but heat energy is something that drives everything. At this point, let's do a quick activity. I want you to pick three technology that use heat in our daily lives. I'm going to go through my example after you write three technologies and briefly explain two. This, there you go. I want you to also explain. Let me go through my example. When I go through, oops, my example, I'm going to write down in the next slide. So one of the technology that I like to share is, like I said, any type of engine. For example, car, car engine. It's a good example. If you like to add my example in addition to yours, of course, feel free. In fact, I encourage you to do. Engines, and I'm gonna change the color so that you know what I wrote. Engine uses, or I like to say burn, fossil fuel. And by having this, by going through this combustion reaction, we can have heat energy. And this heat energy rotate motor. Think about that way. And other part, I can think of oven for cooking. When it comes to traditional oven, we can talk about electricity too. Let's talk about what you see in modern houses, kitchen situation. Electrical energy basically heat up the coil inside of the oven. And once that happens, the chamber inside of the oven heat up, and that will let me cook food. You can think it in that way. And third example, let's put more heat energy, something that we use in winter time, heat pack. Even though Canada doesn't have that much of heat pack, there is some heat packs available. Sometimes people use it for a medical perspective too. I actually remember using a lot in South Korea. Heat pack is used because there's a little chemical reaction going on inside of the pocket, and that pocket releases heat. Certain reaction releases the heat, certain reactions absorbs the heat, which we're going to talk about that later as we go through this unit's journey. But long story short, ladies and gentlemen, if the heat is released, what's going to happen is it warms your body up. And for example, your hands, that's a good example that you can think of. So, although you guys probably share something else like boiler, those kind of thing, but long story short, there are numerous technologies that use heat in our daily lives. And some of the quick example you can think of is COVID. There's one of the big thing that we check. Body temperature, thermometer is also another technology that use heat. So a lot of uh, how can I say example fit into this category as long as you explain like how I did for each of the example. So next I like to find not find sorry I like to go through that heat is a form of energy, ladies and gentlemen. Oops, pen would work better. Form of an energy. I want you to highlight this part. There are lots of different form of energy. Electrical energy, there's a something called potential energy, nuclear energy. Heat energy is one of the most important form of energy that we use because that basically operate everything, especially in terms of machinery. Energy shows a capacity for doing work. There are different forms of energy, like what I showed down there. Like when you see this guy over here, that means it's a windmill. We talk about wind energy, right? So some of the example, there's something called potential energy. Potential energy, you can think about multiple different stuff, but generally people talk about gravitational. So that's something that, for example, if you drop a ball from a certain height, that has a certain energy to give an impact once it all the way fall down and hit the ground, something like that. There's also chemical potential energy. Even though there are many different type of form, these two are one of the common one that you'll see in junior high and high school. Kinetic energy. When people talk about kinetic energy, it's involved with any type of motion related. So things has to move. A good example is think about bicycle. You're pedaling and the bicycle move. That moving part, motion related energy is known as kinetic energy. Thermal energy is something that is related to heat. So I'm going to say that is equal to heat energy, electrical energy, chemical energy, and nuclear energy. Heat is a flow of an energy, ladies and gentlemen. This is one of the most important part of today's lesson. So I want you to copy it first and then look at the diagram. Heat is a direction, a flow of energy because of the difference in temperature between two objects. So when I talk about that, I always talk about some heated object. Let's say I have a fire, campfire, the one that has logs, something like that. Campfire. Heat energy always dissipate. What I mean by that is it disperse because surrounding, so for example, if you're standing over here or someone's standing over here, those two people's body temperature goes up. The reason being is because the heat energy always go from hot object to colder object. Compared to the fire itself, especially when you think about campfire, your body temperature is definitely lower. So that's why the heat energy go from one location to another location, in this case from fire to a person. Something else, you can think about this boiling pot over here. As you may notice, the heat radiation part, the source of heat is coming from the oven pan. Now, however, the heat energy will always go from higher temperature to lower temperature. So that's why heat is dissipated and then it's gonna heat up the water, and water go crazy and bubble around because heat energy is exceeding. This direction from high temperature to low temperature, or heat is happening because of the difference in temperature, is one of the core learning part of today. So why there's a flow of energy is because this energy movement is caused by the movement of atoms and molecules. So for example, if you think about the water over here, water molecules, if they are completely motionless, then what happens is they are turning into ice. Ice is the only part of a form of matter for water that doesn't have any movement. However, if there is a heat energy occurring, then they will be warmed up. And if they're warmed up, they're gonna be melted and they're gonna move around. That's why there's a bubbling occur, because they try to escape that environment, and eventually it's gonna, like what I said, boil. So heat energy excite the atoms and molecules. And when you talk about atoms, although it is important to go through these two, please consider these two in grade 7, that what makes matter. So smallest matters. You can think it in that way. What makes water? What makes your iron pen? Those kind of things. We are gonna develop these two more as time go. Heat always flow, like what I said, higher temperature to lower temperature. That means hot object to cold object. This never change. It is something that happened in this universe, even not only on Earth, but also Jupiter's and any type of other planet or other type of galaxy too. It's known as second law of thermodynamics. Thermodynamic is a fancy way of saying the theory that explains about heat and motion. You can think it in that way. Let's do our second science log activity. I want you to explain why water boils in a pot on a stove. And I want you to write down literally step by step method, detailed step by step, from the very first step all the way to last step. And I want you to think about direction of heat movement. So pause the video and resume it after about 3 minutes. Once you finish it, let me go through each of the steps. First thing first, um, if you're talking about the one that has gas in it, I like to say natural gas uh, combust. That means burns. The natural gas burn. That's the very first step, which is happening at the bottom step over here. Then what's going to happen is metal pot is heated up first. Know the fact that when it comes to heating up situation, you need to understand, or cooling too, you need to understand step by step. Water doesn't boil at the first. The pan or pot actually boil up first. So metal pot, when I talk about metal pot, probably it will be iron pot or any type of others like steel, which is combination of iron, aluminum, and other stuff. Those are the one that you can think of. But in this case, metal pot is heated up first. Then water molecules. I want you to be familiar with it. When it comes to certain chemical, don't put water heat up, water molecules from now on, because we're talking about each little H2O by H2O. Water molecule, which is individual H2O molecules, receive heat energy. That's what happened. I'm going to actually control this a little bit. Number four, why it's kind of hard to write. Number four. All right, number four, water. Water's temperature slowly rises. And at this point, you may observe bubbles. And number five, when it comes to the last part, water starts boil at specific temperature. And this is where you need to think about when is a boiling temperature for water, which if you know about some of the science, it is happening at 100 degrees Celsius. So that is what I want to go through for today's lesson. Before I give you the homework, I'm going to go through this log number 3 as a little review of the last next lesson. I want you to copy any of the step that you missed for this science log activity number 2. And that was today's lesson.